Alright, this video is about the Doppler effect. You've experienced the Doppler effect. You don't really know that you've experienced the Doppler effect, but you have. And here's an example of the Doppler effect in action. Listen. So did you notice it was high pitched, right? That's the Doppler effect. It's the apparent change in pitch or frequency. Apparent, so it's not really changing. It's the apparent change in pitch as an object is moving toward or away from you. So here's what causes the Doppler effect. You can actually open the Doppler effect applet that's on Haiku and you can play around with it and see what's happening. But we're going to give you a little bit of an explanation here. Okay, so in the middle here we have an object that's giving off some sort of sound wave. We don't know really what it is, but it's, it doesn't matter really what pitch it's giving off. But here we're giving off some sort of sound wave, and it is radiating outwards, and so it's going doing, 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 and traveling. Okay, so that's what would happen if everybody were standing still. But what happens is this object in the middle is going to start moving. So let's make this a little bit bigger so we can focus on this guy. So he's going to move, and he's going to move this way, and he's going to kind of catch up with the wave that he just gave off, and he's going to give off a new wave. And then he's going to move, and he's going to give off a wave, but that's going to catch up to the wave that he gave off before. And are you seeing here that he's going to move? And now we have three waves: the one he's given off now, the one he gave off before, the one he gave off before, and the one he originally gave off. So all of these waves are starting to pile up on each other, and what they will look like is this. So as our object is moving to the right, it's piling up the waves a little bit, and so you're having shorter wavelengths. If I were standing here, if I were standing right here, and these waves were passing me, I would experience the shorter wavelength, which I would hear as a higher frequency. If I were standing back here, I would experience longer wavelengths and a lower frequency. But what's important to note is that the frequency that the actual source is giving off has not changed at all. It has not changed. It just appears to have changed. So the real frequency is what the source itself is giving off, but what I perceive or what I appear to hear is a shorter wavelength sound. So as an object is moving towards me, I'm going to hear higher frequencies, and that's what we were hearing in the sound bite that you heard. It was coming towards us. And here it passes us, and now it is a lower frequency because it is going away from us.